Okay, let's take a look at one of our last sections, compound events. Compound means two in one. So a compound event is an event that's made up of two events. And it's two categories. It could be simultaneous, which are the ones we're going to look at here in a second, and then also successive events, meaning that a compound event could be something happening and then something happening afterwards. They're in succession. They're one after another. So there's two categories there. So let's start here with some simultaneous events. So if we pick a marble out of a bag and it's got some array of colors in it, what's the chance that we pull a red or a blue for that one marble that we pick? Well, it could be red or it could be blue. And there are 30 marbles in total. So this would be about an 80% chance. But what's the probability that we pick that marble and it's red and blue? One marble, red and blue. That can't happen, okay? So some things can't happen simultaneously. We could look at picking a red one and then picking a blue one, but that would be a successive event, which we're going to talk about on the next page. So simultaneously, that's not the case. So how do you know which is what? You look for the keyword one or simultaneous. This is one marble we're drawing, and it can't be two colors at once. Okay, if we roll a 20-sided die once, what are the probabilities? Okay, so probabilities are also about successes over the total number of outcomes. So for one dice roll, there's 20 outcomes. But in order to be odd and a multiple of 5, you can only be a 5. 10 doesn't work, and 15 works. So there's only 2 successes out of the 20, which gets us 10%. Okay? So, but if we look at or, so and means that both of them have to happen. But or means that one of them can happen, the other can happen, or both. So I'm going to list out all the numbers up to 20. We're going to circle the ones that would be considered a success. And sometimes this is just the best way to do it. So we got anytime a number's odd, we're going to count it. Okay. And anytime a number is a multiple of 5, we count it as well. So if you tally up all of those, I think we get 12 out of 20, which is 60%. So all those yellow numbers there are they're successes. So we take that over the total, and then that's our probability. Okay. But we also have this rule that's really helpful, this formula called the addition rule. And the addition rule says that if you want to find or, like we just did right here, you can do the probability of one of the events happening plus the probability of the other event happening minus any overlap. So or looks like this. This is considered A or B. And this is considered A and B. All right. So this formula, you can think visually. You can think, okay, we have the A circle, we have the B circle, but if you were to draw those, like, bear with me here, if you were to draw an A circle, and then you were to draw a B circle, but if they have overlap, you can see that this area in the middle is double counted. So if you want a clean single layer, you actually have to subtract the overlap, this overlap. So that's why the formula is structured the way it is. But let's take a look at some more examples then. So we have some tiles, 4 colors, and they're all 1 through 10. So that means we have 40 tiles. So I don't want to write out all 40 tiles. So I'm going to use our formula, which says that if you want it to be blue or a 10, you do the probability of one of them plus the probability of another minus the probability that both happen. Okay, so the probability of pulling a blue would be 1 out of 4 because there are 4 colors. The probability of getting a 10 is there are 4 10s because there's a 10 for every color and there's 40. And then if you want to be blue and a 10, there's only 1 tile that can count for that. So if you add up all these together, get a common denominator first, you get 13 out of 40. So that's the percent chance that when you pick one, it's either blue or it's got a 10, or both. But it's got to have at least 1. Okay? And what about that same question? So again, imagine that we have 10 blacks, 10 pinks, 10 blues, and 10 reds, and they're all numbered. So to get a red or a greater than 5, you would do the probability that you're red plus the probability that you're greater than 5 minus the probability that both of them happen. Because when you add those probabilities together here, you're actually double counting ones that are both red and bigger than 5. So you have to subtract an overlap. That's the reasoning. So to pick a red one would be, there's 10 reds out of the 40 tiles. 6, 7, 8, 9, and 10 are all bigger than 5. So that would be 5 out of 40. I'm sorry. 5 out of 40, but there's 4 colors. So 20 out of 40. Half the tiles are bigger than 5. And which ones are red and bigger than 5? How about these 5 up here? So we do get 25 out of 40. Okay. I'm going to go ahead and pause the video here and go ahead and watch the next one, but I don't want this one to be too long. So actually, let's go ahead and just do a little bit more. Let's do the Venn diagrams. So if an athlete can only participate in one sport, and during the spring, there's you can either be a baseball, or lacrosse. And 28% are in baseball, 24% are in lacrosse. That means that left over, that's 52 in total. So there's 48% of students that aren't in either of those. Okay. The word mutually exclusive means that there's no overlap between them because at this school you can't play both sports. So what's the probability that if you pick someone at random that they play one of the sports? That would just be 52%. Okay. Okay, so that one wasn't quite as interesting because there wasn't any overlap, but this one does. If we have some keys at school and 30 of them open both the doors to the class and to the lounge, and there's 80 keys total, and 40 open the lounge and 60 open classrooms. So inside of this bubble has to be 60. So I'm forced to put a 30 here. And inside of the lounge bubble, there should be 40. So I should put a 10 there. Okay? Meaning that 80 minus all of that is 10. So what's the probability that a key opens no doors? 10, because that's the number that shows up here. Okay. And pet owners, always look for the and first, and that's going to be the middle of your Venn diagram. And then you can do subtraction to figure out the rest. So if the dog bubble has to be 88, but we've already done 31 of it, if we do 88 minus 31, you get 57. And the cat bubble has to have 52. So this has to be 21. Okay. And if we add up all of those together, we get 109, which means we're 42 shy of the 150. So a Venn diagram, keep in mind, has to have 4 numbers. So what's the probability that a randomly selected pet owner owns a cat or a dog? So that would be this segment over here and this segment. But when someone asks this question, hey, do you have a dog or a cat at home? And you have like a bunch of both, you wouldn't say no. You would say, yeah, I do. I have both. So this or is looking for dog, cat, or both. So we actually are looking at the entire interior of the Venn diagram. If someone is in there, that means that they own a cat or dog. So that means that we have 109 out of 150. So around 73%. So or for us in this unit, or means